In this video, I'm going to test your ability of the mastery of skills you learned in the previous 4 videos. So put everything away, take out the blank unit circle that you have. If you need to walk up to the desk and grab one, please do so. And I'm going to start by saying a specific degree, and I want you to find that degree right here. So I'm going to start with 210 degrees. And write that down here for people that are visual learners. 210 degrees. And I'm going to ask you, what is the ordered pair for 210? So how do I walk through doing this myself? Okay, I look at the first two, and I recognize that 3 divides nicely into 21. So what does that tell me? It tells me I'm going to start here, and I'm going to go 3, 6, 9, 12, 15, 18, 21. This is 210 degrees. Now, how do I find the ordered pair? Because they could specifically ask for different types of trig functions. At this point, we've only talked about the cosine and the sine. We can think of this as x and y, cosine and sine. Remember CBS, cosine before sine. So how do I come up with this? Well, I recognize that this angle that helps create 210 degrees, this angle is the same as this angle. This angle right here is the same as this angle. So if I'm able to figure out this ordered pair, I can place it here, and then I can use what I know about the different quadrants in terms of the signs to accurately identify the ordered pair for 210 degrees. So remember, I'm going to make this U shape, and as I do the U shape, I'm going to count 1, 2, 3, 1, 2, 3. There's always going to be a 2 on the bottom of everything. And as I go down, I ask myself, do I know the square root? So square root of 1, yep, I know that's 1. Square root of 2, nope, irrational. Square root of 3, nope, irrational. And I start counting again. Square root of 1, yep, it's 1. Square root of 2, no, it's irrational. Square root of 3, no, it's irrational. So everything I do here except for north, south, east, west is going to relate back to this. This is like a cousin to this angle. The interior is 30 degrees back to what we think of as the x-axis or the cosine. So I write this ordered pair, radical 3 over 2 and 1/2. Remember, quadrant 1, 2, 3, everything's negative in quadrant 3. So if I said to you, what is the cosine of 210 degrees, the cosine would be negative radical 3 over 2. If I said, what is the sine, it would be negative 1/2. Remember, it's always cosine of an angle followed by sine of the angle. CBS, cosine before sine. Let's try another one. Let's try 315 degrees. I'm going to write that down again for the visual learners. 315 degrees. 315. Well, recognize that 31. It ends in a 5, ending in a 0 right now when we talk about only the points that we see that have dots, okay? Ending in a 0 is going to be one of the 3s. So 30, 60, 90, right? 120, 150, down into a 0. If it ends in a 5, it's going to be one of the 45s. This is 4, add 9, 13, add 9, 22, add 9, and 31. So this angle right here is 31, and then attach a 5. This is the 315. That means from this starting line all the way around and to get to this line, from here all the way to here, has an interior angle of 315.
Transition to lunch B.
So how do I come up with the ordered pairs? Well, this is a 45, so it relates back to his cousin, this 45. Radical 2 over 2, radical 2 over 2. In quadrant 4, the cosine is positive and the sine is negative. So again, what is the cosine of 315 degrees? It would be radical 2 over 2. What is the sine of 315? It would be negative radical 3 over 2. Okay, let's jump up right now. Let's go to the next one, and let's say 120 degrees. 120 degrees. Okay, so it ends in a 0, so I'm going to count with 12s. 3, 6, 9, 12. Attach the 0. Now, what is this angle? Always go back to the x-axis, known as the cosine. This interior right here to go down is 60 degrees. So it's going to relate to this angle. It's 60 degrees. That's often really confusing for students. 60 degrees down, the same as this angle, 60 degrees down. So I write down 1/2 and radical 3/2. Remember, this is quadrant 2 in that case. What we think of as the x is negative and the y is positive. So if somebody says to you, what is the sine of 120 degrees? The sine is positive radical 3/2. What is the cosine of 120 degrees? It'd be negative 1/2. Okay, let's change things up. Let's say, what is 4 pi over 3? 4 pi over 3. Oh my goodness. So without looking back and looking at your notes, let's figure out how we can do this. So 4 pi over 3. So I need to change this, the way I do it, into either 4 or a 6. And it's going to be the one that's easiest. So this easily changes into a 6 by multiplying by 2. I'm wondering, why would you do that? You get 8 over 6, because that's what I'm going to use. My 6's are the same as the 30's. Remember how there's one group, there's 30, 30, 30, 30, 30, 30. There's 6 sectors that have an interior angle of 30 degrees. That's why we have a 6 on the bottom. So this is the same as 8 pi over 6, and this will help me by counting to find the right line. So one group of 6, 2 groups, 3 groups, 4 groups, 5 groups, 6, 7, and 8. This is where 8 pi over 6, this is 8 pi over 6, but remember 8 pi over 6 reduces to 4 pi over 3. Now how do I know the ordered pairs? Okay, ask yourself, how far is it from this line back up to the x-axis? And the answer is 60 degrees. There's 30 and 30 is 60. So I find my 60 and I write down what I have, 1/2 and radical 3/2, because it's a cousin to that angle. But in this quadrant, quadrant 3, both terms are negative. Okay, next I want 5 pi over 6. 5 pi over 6. Well, it ends in a 6, so it makes life easy. I'm doing with the same with the 30s. 1 over 6, 2, 6, 3 over 6, 4 over 6. Oh, sorry. 1 over 6, 2 over 6, 3 over 6, 4 over 6. Here's 5 over 6. And 5 over 6 cannot be reduced. Now, how do I figure out this ordered pair? From this line back down to the x-axis is 30 degrees. So radical 3/2 and 1/2. This is the cousin. Radical 3/2 and 1/2. Remember, in quadrant 2, the cosine is negative and the sine is positive. If somebody asked you, what is the cosine of radical 5? Let me go back here. What is the cosine of 5 pi over 6? The answer is negative radical 3/2. If they asked you, what is the sine of 5 pi over 6? The answer is positive 1/2. Okay, let's do another one. Let's go with simply pi. How do I find pi? Well, I know that pi is the same as over 1. So whether I turn that denominator into a 4 or into a 6 is really up to you. Let's go with 4. It's times 4 and times 4. So I'm looking for 4 pi over 4. Okay, so I'm counting by 4s. There's 1 over 4, 2 over 4, 3 over 4, 4 over 4. So this is 4 pi over 4, which is the same as 1 pi. It's also what, when I use the directions, this is north, south, east, and west. To get here, we know the radius is a distance of 1, so I go 1 to the left, and then I do not go up and down. If you were asked what is the sine of 1 pi, the answer is 0. If you were asked what is the cosine of 1 pi, it would be negative 1. Okay, let's go with 5 pi over 3. Where is 5 pi over 3 without looking back and referring to your notes? Well, is it easier to turn the denominator into a 4 or a 6? That will be your answer, and it's easier to turn into a 6 by multiplying by 2. So once you have it up to a 4 or 6, in this case 6, that helps with counting. I always start here. I don't count this as 1. Once I move, it's 1. So 1, 2, 3. I'm going 10 times, by the way. I'll start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 pi over 6, which reduces to 5 pi over 3. How do I know what the ordered pairs would be? Okay, What is the distance from that line back to the x-axis? That would be 30 degrees. 30 and 30 is 60. I think I said 30, I meant to say 60, excuse me. 30 and 30 is 60. So I go up to 60 and I'm writing down 1/2 and radical 3/2. Remember, this is quadrant 4. In this case, the x is positive and the y, known as the sign, is negative. So what is the cosine of 5 pi over 3? It would be 1/2. What is the sine of 5 pi over 3? It would be negative 1/2. Please fill in the missing parts. So fill in for me, please. Go back and fill in at this time. The missing degrees, the missing radians, and all the missing ordered pairs.